Hey everyone, in this video we're going to be talking about if a function has an inverse just based off of its graph. Now, if we think back to, or if you watch my other video, what is a function, you'll remember that I talked about something called the vertical line test, right? So, what I did for the vertical line test is I took a line and I moved it across my function, and if it passed the vertical line test, it was a function, right? But when we're talking about an inverse, I'm just going to slide that over here, what I'm concerned about is if it passes what's called the horizontal line test. So just like the vertical line test, or similar to the vertical line test, I'm going to take a line and make it horizontal and move it through the graph. And if at any point there's 2 points on the graph that intersect with this horizontal line, let's make that red again. So if I have 2 points on my horizontal line and graph that intersect, it does not have an inverse. So 2 or more intersections means no inverse. So it has to pass the horizontal line test in order for the function to have an inverse. Alright, so let's look at 2 examples of this. Alright, so example 1 is going to be, let's use the graph of y equals x cubed, which is something that everyone should be familiar with at this point. We know that looks something like this, right? That's y equals x cubed. And determine if it has an inverse, what I'm going to do is take a horizontal line. That seems pretty horizontal. And I take my line and I move it through the graph, like so. Right? I keep on moving it through the graph. Now, if at any point the horizontal line and my graph intersect more than once, it does not have an inverse. But I can see here that at any point that I move this line, I keep on doing that. At any point that I move this line, right, I only have one intersection all through the graph. So this does have an inverse. All right. So the function y equals x cubed does have an inverse, and does have an inverse because it passes, it passes the horizontal line test, HLT for short. Alright, so let's look at another one. Alright, for this example, I'm not going to give a function. I'm just going to kind of draw a crazy looking picture. So let's look at this function. Alright, now I want to draw my horizontal line. That looks pretty good to me. And I move it through the graph. And immediately I start seeing that I have more than one intersection. So let's just stop right here. And I can mark it on my horizontal line. I have 1, 2, 3, 4 intersections. As soon as I get that just one spot on my graph has more than one intersection, I'm done. I don't need to go any further. So this is no inverse. Right? So for example, if I put my line, can I move this? No, I can't move that. I'll draw a new one. If I started down here, right, it only intersects at 2 spots. Right here and right here. As soon as that happens, there's no inverse. I don't need to check anymore. Once I see that there's just one point on my graph, or one section of my graph that has more than one intersection with the horizontal line, it's done for, and there's no inverse. And the reason there's no inverse, is this is going into a little bit more detail, is because when I look at the inverse of a function, I switch my x's with my y's. right? My y's become x, and my x becomes y. And remember, a function has to pass the for something to be a function, it has to pass the vertical line test. So if I swap all of my y's here with x's, I have a bunch of y values repeating. Let's say this y value is, let's say -2. But then I have this x value, this x value, this x value, and then this x value. So I'm going to get, let's say this is the x value 1, let's say this is 5, and this is 10. Ooh, that's a terrible 0. Let's say this is like -7 for my x's. So I have all the ordered pairs of my original function is going to be, right, 1, -2, 5, -2, 10, -2, and then -7, -2. So these are the points in my original function, right? But then when I go to the inverse, so let's do the inverse. So I swap all my x's and y's, so I'm going to get -2, 1, -2, 10, -2, 5, and then -2, -7. So for my inverse, it's going to send -2 to 1, -2 to 5, -2 to 10, and -2 to -7. And that is a problem, right? My x values can only go to one y value in order for it to be a function. And so that's another reason why that if it doesn't pass the horizontal line test, that my original function does not have an inverse, because the inverse will not be a function itself. Okay, well, that is everything for determining if a function has an inverse based off of its graph. If you have any questions or comments, please let me know. Thanks for watching. Bye.